So continuing on with more ratios and proportions. Here, I just want to point out some vocabulary that I don't know if we have discussed. Okay, if we have a proportion, we call A and D, okay, these numbers, A and D, they are called the extremes. They're like on the outside of the proportion, and if we look at B and C, we would call those the means. Alright, just to give some vocabulary so when I talk about this it won't be strange. Alright, so we have right here one other way of writing this proportion, A over B equals C over D, would be to write it so that it's flipped over. Alright, so you can think about this as it being flipped over. All that changed is we flipped, oh that doesn't say flip, does it? Okay, close enough. So we have flipped over each fraction. If we cross multiply, we get AD equals BC on this side. And if we cross multiply, we can again get AD equals BC. So we know that they are the same. Another way to rewrite this proportion would be to switch the means, okay, or switch the extremes. So if you take a look at this, we have if A over B equals C over D, then we also know that A over C equals B over D. So see, we just sort of flipped or switched the means. Okay, so we can switch the means or extremes. If you cross multiply, you'll see that you end up with the same thing. On the left hand side, we know we get D equals BC, and on the right hand side, A times D equals B times C. Alright, the last one can be a bit confusing, and I can go over the math in class, but if you add the denominator to the numerator, it keeps the fraction the same. Okay, and I'll go over a bit of this in class, as long as you remind me, because this one is a really neat property, and it has something to do with the denominators. So we'll go over some examples here. Tell whether the statement is true or false. Well, if you know your properties, you know that you can just switch the means and the extremes, means or the extremes. Alright, so I can write it this way, 3 over 6. If I simplify here, I get R over Q equals 1 over 2, which is the same thing. So that is true. Another way to check it would be to cross multiply. So on this side, I'd get 6R equals 3Q. I could divide both sides by 3, and I would get 2R equals Q. Over here, we would have 2R equals 1Q, which is the same, so we know that they're good. Okay. Example 2, tell whether these are true or false. Alright, so it looks like a whole bunch of things were done here. The fractions were flipped. Alright, so let's see, if we flip each of these fractions over, they are still exactly the same. And again, we can check by cross multiplying. Oops. 6R equals 3Q. On this side, we would get 3Q equals 6R. Those are the same, so we know we're good. This one is a little bit tougher to prove algebraically. So did they just take the denominator and add it to the numerator? So that would be R plus the denominator is 3. Alright, the numerator, in this case, is R plus 3 now. On this side, we just add what's in the denominator, and we get that. So is that the same? No, it's not. So we're thinking it's false. We could check by cross multiplying. Alright, so we know this is 6R equals 3Q. On this side, we get 6 times R plus 3 equals 3 times Q plus 3. So we're thinking this isn't going to work. All right, we get 6R plus 18. All right, equals 3Q plus 9. All right, I'll just move this 18 over, so I get 6R equals 3Q minus 9. Are these the same? And we'd say no, so they are not equivalent. All right, example 4. If P over Q equals 7 over 10, if we flip the front one, we should just be able to flip the second ratio, which should be 10 over 7. All right, if on number 2, which it looks like it's getting to that, okay, 10 over 7, come on. This one here, if we do P over 7, we're just switching our means here. P over 7 should equal Q over 10. Alright, and it looks like we just added the denominator here. So if we add the denominator to this side, 7 plus 10 over 10, or 17 over 10. And if you guys have questions about that third one, we'll talk about it in class. At this point, I would like you to pause the video and try to answer these. Make sure you write these down in your notes. We will discuss them in class. Okay, continuing on, next example. James, Michelle, and Angela have $50 in a ratio of 2 to 5 to 3. So we're talking about an extended ratio here. It doesn't mean that James has $2, Michelle has 5, and Angela has 3. It's that they're in this amount, 2 times something, 5 times something, and 3 times something. Okay, so if we set up an equation here, we could figure out James' amount plus Michelle's amount plus Angela's amount. We know it has to equal $50. So now just put those things that I wrote in there. All right, so you get 2x plus 5x plus 3x equals 50. Add those together, we get 10x equals 50. Divide by 5, we have $5. That doesn't answer our question though. How much money do they each have? So now you have to take it and plug it back in. Alright, so we get James' amount has 2 times 5 or $10. Michelle's has 25. Angela has 15. And we should double check, do they add up to 50? And it looks like we're good. Okay, the next example. We have on a map, here is the scale listed on the map. And we're looking at the distance between Trenton, New Jersey and Washington, D.C. On the map, it is 0.76 inches. So we're trying to find the actual distance. Oh, here is one way we could do it. 1 inch over 200 miles, because we know that's true, is 0.76 inches over how many miles? Alright, another way we could do it, if we just switch some things, we get 0.76 inches over 1 inch. Oh, that's an N. Okay, 1 inch equals how many miles over 200 miles. So that's just another way. Either way, you're going to get the same answer here. So cross multiply and solve, and we get x is 152. So we should answer the question. The actual distance between Trenton and Washington, D.C. is 152 miles. Alright, Maria and Omar have $75 and a ratio of 9 to 6. How much do they each have? Okay, so we're thinking 9x plus 6x. If we add up their money, we should get $75. Okay, 9x plus 6x, 15x equals 75. Divide by 15. So x equals 5. Alright, how much do they each have? Well, for Maria, okay, it's 9 times 5. Maria has $45. And then Omar, 6 times 5, would have $30. To double check, do they add up to 75? Yes, they do, so we are good. Okay, so here are your last three problems. I'd like you to take some time, pause it, work through this, and then have your answers ready in class tomorrow.